So let's take a look at the last two examples, which are distance, rate, time examples. And these tend to be the hardest because people want to use R for rate, and really the question itself here is asking for a speed of the plane in still air and the speed of the wind. So those are actually both rates. This is a rate and this is a rate. So how am I going to make this work? Well, that's going to be my x and my y. So instead of r, I'm going to say x is going to be the rate of the plane. And instead of r, I'm going to say y is the rate of the wind. So you might be confused because we have r here and I've got two different rates, but the rate is going to actually be the sum or difference of those two. So let's take a look at this in the first leg of the flight. So the first leg of the flight, again 660 from Atlanta to Miami, is 1.2 hours when traveling with a tailwind. So let's make a sentence or a mathematical sentence out of all of that. So distance equals rate times time would be 660 equals, what's the rate? Well, the rate is with a tailwind. So with a tailwind means the wind is blowing at the back of the plane, helping the plane go faster, which means it's the rate of the plane being assisted by or going faster using the rate of the wind. The time is 1.2 hours. So the return flight, also 660, but it takes 1.5 hours and it's against the wind. So against the same wind means the rate would be the rate of the plane not being helped by the wind, but in fact going slower because the plane is blowing into the wind. The time is 1.5 hours. So there's my two equations. So step one, step two. Now, this question is similar to an assessment question, and what a lot of people want to do is go ahead and simplify this on their own, not showing that work. I want to see these two equations. Step three, you can simplify to your heart's content. So step three, I'm going to then, and you can choose to do it a couple of different ways. Some people are like, okay, well, let's go ahead and distribute that 1.2. But what I find is easier is if I take 660, whoa, hold on, 660 equals 1.2 x plus y. If I take each side divided by 1.2, it's actually going to work out better. So 660 divided by 1.2 actually gives me 550. And looking at what happens here, on this side I'm just going to get x plus y. And you might think, well, why would I do that? Why not just distribute? Well, let's take a look at what happens when I do that same step for my next equation. If I have that 660 equals 1.5 times x minus y, and I divide by 1.5, 660 divided by 1.5 gives me 440. And then what's left on the other side? X minus y. So why does that bring so much joy to my heart? Because I can use elimination right now, because these guys are the same number opposite sign and they're going to cancel out. So what happens? I get 990 equals x plus x, which is 2x. These guys cancel. 990 divided by 2, 495. So 495 equals x. What's y? Well, I can plug it into any of those equations. So I'm going to actually choose to plug it into 550, equals x plus y, which is this equation. 550 equals 495 plus y, which means 55 equals y. Again, step 4, write that sentence. So my sentence would say, the speed of the plane in still air is 495 miles per hour. The rate of the wind is 55 miles per hour. That's a really strong wind, but you get the idea. Really similar example for you to try on your own. So press pause, try this question, then press play to see how you did. Again, the final question says, what's the rate of the plane in still air? So I'm going to call that x. X is rate of plane. And what was the rate of the wind? So y equals rate of wind. Those are the two things I'm trying to solve for, so those are my two variables. We're still using d equals rt, distance equals rate times time. My first one, 450 miles is the distance, and with the wind, 3 hours. So just like last time, I'm either going to be adding or subtracting the two rates together. So if it's flying with the wind, distance is 450. Rate is the rate of the plane plus the rate of the wind, because it is with the wind is helping it. Time is 3 hours. The second equation would be against the wind, 5 hours, still 450 miles. So 450 is distance. Rate against the wind would be the rate of the plane minus the rate of the wind, and then 5 hours. So there's my two equations. Again, in the instructions I say don't simplify before you give them to me. So this is step 2 right here. Step 3 is when I can start to do some of my work. So for step 3, I'm going to divide this whole equation by 3. So 450 becomes 150. And then this 3 and this 3 cancel to give me x plus y, just like on our last example. And then I'm also going to do the same thing with my other equation. I'm going to divide everything by 3. So by 5, not 3. Dividing 450 by 5 gives me 90. This 5 and this 5 cancel because it's 5 divided by 5, which leaves me with x minus y. And then from here I can start simplifying, which is what I want to do. So I'm going to get, if I add these together, that would be 240 equals 2x, y's cancel, divide by 2, 120 equals x. To find y, I'm going to use 150 equals x plus y, which is this guy right here. 150 equals 120 plus y. 30 equals y. Step 4, write that sentence. The sentence would say, the rate of the plane in still air is 120 miles per hour. The rate of the wind is 30 miles per hour.